Hey, this is our next INB for section 1.2 in the book, and this is solving equations with one variable. And so this would be a blast from the past from Algebra 1. Most of it will be a review. There might be a couple tricks that you hadn't seen. First one is just solving for x. We're going to distribute. So I get 6x minus 6 plus 4 is equal to, distribute again, 21x plus 3. Got variables on both sides, so I'm going to subtract the 21x over, reduce these out, bring anything that I didn't work with. I can combine these like terms right here. I could get -2, and then I can get -20. This should be what, -15x, and then I'm going to add 2, get -15x 5, divide by -15, and I get x is equal to -1/3. No decimals ever in math, unless if the problem has a decimal or it deals with money or something, which would probably have a decimal. Other than that, we always want a fraction and one that's in proper form, not a mixed number. Okay, number 2, here's a strategy that we're going to use, especially moving on to harder problems. Notice I don't like fractions, so what I'm going to do is I'm going to get rid of my fractions right away. So what I'm going to do is I'm going to look at 3 and I'm going to look at 4 and I'm going to say what number are both of these 3 and 4 divisible by, and I'm going to try to pick the smallest number, which ends up being 12. 12 is the smallest number that is evenly divisible by 3 and evenly divisible by 4. And then what I'm going to do is I'm going to multiply all 3 pieces, right? So when I multiply, I got to do to everything. So I'm going to do 12x divided by 3 plus, and then I have this 12. I'm going to leave it out in front of the 3x here. And that's because I want the 12 to reduce. So up here when I multiplied by 12, it's not going to bump up the number. And so I get 12 divided by 3 is 4x. 12 divided by 4 is 3. And notice I still have to multiply it by that 3x. I get 24. I would get 4x plus 9x, 4. I get 13x equals 24. And I'm going to divide by 13. And I get x equals 4. Okay. So my next problem is going to look like number 3. Okay. So this is the reason why we just learned to multiply by kind of like the least common denominator, right? So if like we were going to combine those fractions, that would be the common denominator. So again, I'm going to look at this fraction and I'm going to factor everything this time. X minus 2, x plus 2, x minus 2, x plus 2. Okay, so my goal again is just like we did the 12, is what I want to do with these x minus 2 and x plus 2. So remember, our goal is every denominator to be reduced out evenly, so I don't have a denominator anymore. So what would this one need? An x minus 2. What would this one need? An x plus 2. Okay, well, you can't do one thing to one fraction and do something different to another part. So if I'm going to multiply this one by x minus 2, I've got to multiply this one by x minus 2. If I multiply this one by an x plus 2, this one needs to be multiplied by an x plus 2. So I'm doing the same exact thing to everything. Okay, so now I know I've got to multiply this one by an x plus 2 and x minus 2. Well, that ends up to be perfect because this fraction needed both an x minus 2 and an x plus 2. Now I'm going to go ahead and I'm going to reduce these off. x minus 2 and an x minus 2 reduce. Notice that I'm not multiplying anything through. I'm going to put my factors in the numerator by multiplication, and then I'm going to reduce off the denominators. That's the whole goal. And now I'm going to rewrite my function with what's left over. As I'm using parentheses, then I'm going to come back and I have a problem like number 1. Right? Got a couple parentheses. I could distribute. Distributing a 1 doesn't change anything. 3x minus 6 minus 6x. On the right side, I got a couple like terms combined and get a negative 3x minus 6. And add my 3x over, get my variable to the same side. 4x plus 2 is equal to negative 6x. Subtract a minus 2. Divide by 4. And I get negative 2. Okay. The last thing that I want to check is that because these are rational functions, I have 3 possibilities, well, 2 possibilities, right? Because this one factors to include this last 2 ones, right? Of input values that would cause this function to be 0. So when I'm done solving this way, I have to go back up and make sure the value that I found, or value, sometimes you have multiple, does not cause my denominator to become 0. So notice on this factor, x could not equal, or this fraction, x could not equal 2. This one, x cannot equal negative 2. And this one, x cannot equal 2 or negative 2. And notice what I got. I got the solution to this equation would be if x equals negative 2. Well, right when I plug it into this one or this one, I'm going to get a 0 in the denominator. So we call this an extraneous solution. One that we thought would be a solution, but ended not being a solution when I checked my answer, because it ends up being a place that caused my my denominator to be 0. So what do? I say this is not a solution. And since I didn't find an additional solution, what happens is I just say this thing has no solution. Okay, because the one solution that I did find is not a solution. Now, sometimes when you work these, you'll turn into a quadratic and you'll end up finding 2 solutions. One of them won't be, so the other one is. Sometimes it can be that there are no solutions. Number 4, what am I going to do? I'm going to find the x and y intercepts of the following easy equation. So I'm going to kind of split this up to the T chart. Got my x-intercept, got y-intercept. We're going to use the property. I know at an x-intercept would be a good example, would be a 5, 0, and a y-intercept would be 0, 5. Right? So the property says for an x-intercept, this is always going to hold true. My y is equal to 0, and on my y-intercept, my x is equal to 0. So what I'm going to do is use that property. So on this equation, y is equal to 4x plus 1. I'm going to plug in 0 for y. And for this one over here, use the same equation, and I'm going to plug in 0 for x. So on my y-intercept, this one's pretty easy because it's 4 times 0 is 0, and I get y 1 by itself. So I know this one is 0, 1, which we should have already known. This is y equals mx plus b form. And this one I'm just going to have to solve. Divide by 4. And x is equal to negative 4. So if I wrote that as a coordinate point, it would be negative 4, 4, comma, 0. Because I set my y equal to 0. And this one, my x is 0 because I set my x of the function equal to 0. Okay, hope that helps. and I'll see you all for test day Thursday, Friday.